Get this, Ibrahim? Tell me.
So I took m, that will be equal to 1 divided by 100 divided by 1.4. Just a second.
But you need to
Yeah.
remember the formula or how you started in a layman language without getting into too much formula. Just how can I do it? Yeah, tell me.
Okay, so we'll take 1.4. No, wait, no. What we can do? Weight percentage we can take.
Yes,
Yeah.
exactly. We can start from 1.4 also. We can start from 8% also.
Oh, okay, okay, okay,
You
okay,
can move both ways.
okay, okay, okay.
Okay,
So yeah,
suppose, yeah, yeah. Tell me if we start with weight percentage, then
what we get? 63. Because
hmm.
so no, in a 100 gram solution you have 63 grams HNO3. Yeah, because
Yeah,
63%.
exactly. Yes, yes,
So
yes,
weight percent will be 63 times
yes.
density. That's 1.4.
Yeah, 63 grams of HNO3 is there
Yeah, so 63 into 1.4, that's
in
density.
100 grams of solution,
Yeah, yeah.
total solution. And this is how many moles?
We will get one.
Yeah,
One.
always keep in mind what we need to get, where we want to go. We want to go up to molarity. So molarity in the numerator, we need the moles of. Yeah, Jasleen, correct. Good. So in molarity, we need to get the moles of HNO3. So 1 mole. 63 is the molar mass. So 1 mole in 100 gram of solution. But in molarity, in the denominator, we need volume. So we divide this mass by density. That is 1.4 gram. This will become ml. And because this is in ml, I will multiply it by 1000 to make it in liters. So this is 1.4 will go in the numerator. It is going to be 40. Yes, correct. Got it? So this is how I'm going to proceed. A very famous, very common question. I hope all of you can do it very well. Okay. This question is also similar to based on in NCRT and been asked many times. So both of you have given the correct answer for the previous one. So let's check this one. Aqueous solution of AI. So let's check it. This also we are going to do it in the same way 20. So normally if the quantity is not given and if the percentage is given, but the overall quantity of the solution is not given, I start with 100. So 100 gram of solution. 100 gram of solution contain 20 gram of Ki. That's what mass percentage means. Right? I will split it into 20 gram KI and the out of total, because this is aqueous solution, so 80 gram is going to be water, right? 80 gram is going to be water. Okay. So now we are going to just okay, Jaslin, you are getting option B and Ibrahim is getting option C. Let's check it. I need to keep one thing in mind. What I need to get, there are a lot of fancy formulas given in the books and being taught by a lot of teachers. Students forget these formulas, right? Most of the time, they are of no use. Just be very simple. Okay. So we are given with the mass percentage. That's what this mass percentage mean. I have written in a very simple words. And what I need to get, I need to get molality. Molality means moles of Ki in the numerator, and in the denominator I need to have just mass of water. That's it. I need to have the mass of water in the denominator. And the data is already with us. So 20 gram Ki is there in 100 gram of solution, and 100 gram of solution is actually having 80 grams of water. Is it clear? How many moles of Ki are there? Divided by 166. Okay. What is the mass of water that need to be taken in kilogram? So I will divide it by 1000 to get it converted into kilograms. So the answer is going to be 20 by 166 into 0.0. It is going to be 22,000 by 8 into 166. It is 250 by 166. So how much we are getting? We are getting 1.506. Actually, you have to be very careful while doing the calculation because all options are very close to each other. So, Jaslin, is it clear? Ibrahim,
Yes, sir. Yes, sir. 1.506. 1.5.
right, Jaslin? And I don't use any of the fancy formulas. My approach is very simple. Okay, what is given to you and what you want. What you want, you just try to get whatever you want in the final concentration terms. For example, you need the moles of Ki in the numerator. That we got by dividing 20 by 166. In the denominator, you need mass of water. That's it. So just be very simple in doing your calculations. Okay. So all these problems are there in the exemplar, NCRT, similar problems, and NEET also. A lot of questions are being asked in recent past 10 years papers. If you go through them, you will find a lot of questions. Got it? The mole fraction of solvent, I would like to draw your attention. This is the word which all of us miss, solvent. Mole fraction of solvent. This is very important to know. In aqueous solution is 0.8. And as a solution is either having, it is a mixture of solute and solvent. Mole fraction of solute is going to be 0.8. So if somebody gives me percentage, I start with 100. So that is the most convenient way. Okay, let's check it, Ibrahim. Jasleen, what about you?
So 1 second.
So if somebody gives me a fraction, so it will be easier for me to take the total moles to be 1, because fraction means out of 1. So out of 1 mole, we are having 0.2 mole of the solute and 0.8 mole of the water, aqueous. And that is very simple now. Out of total 1 mole, solute at 0.8 moles. Water, because you are having aqueous solution. Clear? And we need to get molality. In the numerator, you want moles of solute, 0.2. In the denominator, you need to get the mass of solvent in kilogram. So you have 0.8 moles of water. Its molar mass is 18 gram per mole. This is the total mass of the water divided by 1000 to get it converted into kilogram. So 0.2 into 1000 by 0.8 into 80. Okay. So it is going to be 1000 by 4 into 18. 250 by 18, that is 9, and 125. It is going to be 13.88. Yes. Jasleen, is it clear or not?
Yes, sir.
Got it. So this is how we are going to do. Ibrahim, method is clear.
Yes.
This is very easy. Direct question because the quantities are directly mentioned. So every time you don't expect a tough question. Got it? So what is going to be the answer? Correct. This question is straightforward. Not much details, right? Just directly you can. Moles of NaOH will be 8 by 40, and moles of water, 1 mole of water. 1 by 5, 0.2 moles in 1 mole of water. The mole fraction of NaOH is 0.2 by 1.2, right? 1 by 6. Got it? That is very clear. So now, yeah, right. Jaslin, I hope this is quite easy problem for you also. This is bit tricky. This is JEE advanced, but very easy problem, so that it's actually bit tricky. So I have included it, but very easy also. So there is a compound solute. Okay, I will help you out. And the molecular weight is 80. There is a solute whose molecular weight is 80. It is put into solvent. Solute is H2SX. And we assume that there is no change in the volume, but there is a change in the mass. There is no change in the volume because yeah, right. There is no change in the volume because generally when you mix small amount of solid in liquid, the volume almost remains same, right? So this is the basic uh, ex- uh, theory given in the question. Now what is being asked? The solution is 3.2 molar. So what is going to be the modality? What is the modality of 3.2 molar solution? So 3.2 molar is 3.2 moles of solute in 1 liter. But But as the question is telling the volume of the solution and solvent are same, because upon putting the solute there is no change in volume. So 3.2 moles in 1 liter of solvent. Right, Jasleen? Do you agree with it?
Yes, sir.
And now we need to get molality. So in numerator we need to 3.2 mole of the solute, that is already there. In denominator we need the mass of solvent in kilogram. We can get the mass of the solvent very easily. Ibrahim, how we are going to get the mass of the solvent?
The mass, I don't think we need, yeah, such, because
In the denominator, molality,
that's 1 liter.
moles divided by mass of the solvent.
Oh, okay.
3.2.
Mass is 0.4. Mass will be 0.4
Yeah,
kilograms.
yeah. It is 0.4 for 1 ml. So for 1000 milliliters, I multiplied this volume in 1000 ml by 0.4. So that is a mass. And divide by 0.4 to make it the 1000 to make it kgs. So it is 8. So you have volume of solvent, you have density of solvent, you have mass of solvent. Convert it to kg. Numerator you already having 3.2 moles. So the question is very easy, right? So this, I hope this was given, and similar question was asked in NEET also. Same question, the density is given, and take it. I will not solve it. We have solved it for HNO3 today. Got it? This is very easy. Just tell me the answer quickly. Yeah, Jasleen. Ibrahim, tell me quickly the answer. This is very easy. So what amount of sugar you need to prepare 0.1 molar aqueous solution of sugar, which is having the total volume is 2 liters. Yes, correct. So this is quite simple. All of you have answered it. So this is 1 liter as 0.1 mole, and 2 liters will have 0.2 moles. Okay. 0.2 into 352. 352 is the molar mass. This is the last question of concentration terms and bit tricky, but easy. So this is also related to purity. Okay. So 10 milligram of a tablet is there, right? And it was reacted with acid. It is bicarbonate. and the bicarbonate is reacted with acid and it was converted to CO2. 0.25 ml of CO2. This is at 298 Kelvin and 1 bar pressure. STP, normal, room temperature pressure, not STP. So if 1 mole of the CO2 is having a 25-liter volume, how many moles are being generated in this? How we are going to get the moles? Any idea? Ibrahim and Jaslin, tell me. This is clear. Molar volume is 25 liter. 25,000 ml makes 1 mole. So 0.25 ml of carbon dioxide will make how many moles? They will make 10 to the power minus 5 more. This is just like yes, Ibrahim. This is just like moles of a gas can be calculated by dividing the given volume with molar volume. Jaslin, you must have studied in class 11, right? This formula
Yes, sir.
for gases. For gases, normally at STP, the molar volume is 22.7 liters. That is mentioned in NCRT also in the first chapter. But in this condition, they have given 25 liters. So we are going to get the moles of CO2 by dividing the given volume with molar volume. Okay, and that is giving us 10 to the power minus 5 moles of CO2. So CO2 is being generated by NHCO3. So NHCO3 will also have that many moles, and you can get the mass of NHCO3 from that mass of NHCO3 divided by total mass 10 milligrams into 100. That is going to give us the percentage, and that is going to be 8.4. Right? Clear? So let me take some questions of the colligative properties. And they are also very important. This we have already done. I hope all of you can do it. Just look at the problem and tell me. 98% H2SO4. 100 gram of the solution is having 98 grams of H2SO4. 1 mole of H2SO4 in 100 grams. So it is 1 mole in 100 by 1.8. And then you are going to apply N1 V1 equal to N2. So what should be the answer? Just tell me quickly. This is from NEET 2007 paper. Just one extra thing is added in the last statement. What is going to be the answer? So whatever the molarity you get initially, how much volume of that initial acid you require to make 1 liter 0.1 molar H2S. It is going to be 5.55 ml. Are you getting my point or not?
Yes, sir.
Ibrahim, what answer you got?
I wrote here, I got, how much I got? 55.55. No, sorry, 5.55, 5.55.
Justly, this is the same question which we did. Okay, just one extra point is added to it, right? This is easy, require no calculation, just reading. Tell me, this is quite easy. Here's a screen. Yeah, Ibrahim. Justine, what approach are we going to follow? No calculation, just simply you can tell. Because the data which is given is quite easy. In the solution, you are having equal moles of benzene and toluene. The vapor pressure of benzene is higher than that of toluene, right? Yes, Justine, correct. So vapor pressure is higher means benzene is more volatile. More vapor will form for benzene and less will form for toluene. You can see the pressures also. The toluene vapor pressure is 3.85, and for benzene it is 12.8. So benzene is more volatile. So, and they were having equal moles in solution. When they get into the vapors will be rich in benzene. Okay, so vapors will, because benzene is more volatile, it is having higher vapor pressure. Right, so I hope this is clear. Okay, so C is the right answer. So all of you given the correct answer. This same question has been repeated 2 times in NEET itself and in JEE Advanced also. So just tell me quickly. This is also very easy. For an ideal solution, the correct option is, yeah, you need to look for the correct option. Yes, Ibrahim. What about you, Jaslin? Ideal solution. Gibbs free energy change for mixing should be, Ibrahim, what should be the sign of Gibbs free energy change?
For spontaneous, it should be
Yes.
positive, yeah?
No, it is negative.
Oh,
It is just like the potential energy. Okay. We will be doing it in so Gibbs free energy change as the reaction is progressing. The Gibbs free energy should decrease. It is just like a ball moving forward. It can move forward if its potential energy is decreasing. That you know already. So same is the case with the chemical reaction. If the energy is negative, if it is decreasing, this is spontaneous. If the Gibbs free energy changes zero, that is equilibrium condition. And as if we move ahead, if the potential energy increases, the system, the ball will not go up on its own. You need to push, you need to put some work. Same is the case with chemical reaction. If the Gibbs free energy is increasing, that is positive. The reaction is non-spontaneous. We are going to discuss the same thing in our electrochemistry chapter also. So for spontaneous processes, Gibbs free energy change for the mixing is going to be negative. And entropy is the disorder. If you are mixing the two things, the disorder is increasing. So that should be positive. So first option should be negative. Second option should be positive. Third option should be equal to 0. So first, second, and third are incorrect. And the last option is correct. Got it? This again asked in NEET. So just tell me what is the answer. They are asking the incorrect. One for the ideal solution. Yeah, right. Jaslin, what about the incorrect option? Ideal solution delta H mixing is 0. Change in internal energy is 0. Delta U mixing is 0. The pressure observed and the pressure calculated from Raoult's law are same, so their difference is 0. But for ideal solution, because you are mixing and mixing is happening on its own, it is spontaneous, so delta G is negative. Got it? So the option D is the incorrect one. I hope this is clear. Maximum boiling azeotrope. Next one. That one is clear. Jaslin, I hope that previous question is clear.
Yes, sir.
Okay, great. Maximum boiling azeotrope, that the system that is formed by non-ideal solution, and which where you require more heat to boil. Boiling point increases. It happens when the vapor pressure decreases. If the vapor pressure is lower than the Raoult's law, whatever is predicted by the Raoult's law, if the vapor pressure is lower, then you need to heat the solution more strongly. and that becomes a high boiling azeotrope or maximum boiling azeotrope. Clear? High boiling azeotrope or maximum boiling azeotrope. So Ibrahim, what is going to be the answer?
Will it be ethanol plus water? I think.
Jasleen, you are correct. Ethanol and water are actually, water is having more stronger hydrogen bonding, and when you put ethanol into it, the vapor pressure increases. If the vapor pressure increases, it will boil at a lower temperature. Or you can just compare the binding. The first one is ideal solution. A is ideal. Water and nitric acid are going to bind each other very strongly because the hydrogen bonding is much stronger between the water and nitric acid. Nitric acid is very polar HNO3. So by that also you can assume that this is going to be very strong and you require more heating. Okay, it is going to be maximum boiling azeotrope, but water and ethanol is going to form a loose hydrogen bonding which is weaker. And if it is weaker, you need lesser temperature to boil it. So that C, option C is minimum boiling azeotrope. Option B or the second option is higher or maximum boiling azeotrope. So B is the right answer. Got it? This is also a similar question. Jasleen, what about this one? Ibrahim? Yeah, tell me. This is same as that of water and nitric acid. They bind each other very strongly. Similarly, the water and HCl also bind each other very strongly. And when they bind each other very strongly, their vapor pressure is going to be less. So they will show negative deviation and they will form high or maximum boiling agent. So option 2 is the correct option. Is that clear? Ibrahim and Jasleen, water mixed into nitric acid mixed into water, and HCl mixed into water. Both form high boiling azeotrope and both show negative deviation. Their vapor pressure is lower than expected. Okay. This is also easy question. So mole fraction in vapor phase of some component is x1 and in solution of the same component is x2. In the solution it is x2. In the vapor mole fraction of A. Got it? So now we can figure out what is the relationship between the total pressure and the vapor pressure. So mole fraction in vapor phase will be equal to, in terms of pressure, it is the partial pressure divided by total pressure. Got it? Partial pressure of A is P. That will be equal to PA naught into x2, mole fraction of A in the solution, divided by the total pressure. Right? Total pressure is going to be PA naught x2 by x1. Mole fraction in vapor phase is partial pressure of A into total pressure. Total pressure is the test. Option A is the right answer. Ibrahim, is this clear or not? Teslim?
Yes.
Right. So let's go to the next problem. This is also related to colligative property. Just you need to think and answer. If you can clearly think, you can answer it quickly, right? So molality of solution of X and Y are same, equimolar. That is mentioned in the question itself, you can see. 0.2 mole per kg and both the solutions are equimolar. If the molality is same, the boiling point elevation may or may not be same. Because molality into Kb, it doesn't matter whether it is X or Y because it is a colligative property. As far as the molality is same, Kb into N is same. But there is one more thing which you need to take into account, that is the I. You need to multiply with the Van der factor. Remember we discussed that. Got it? So momentum factor I basically is needed to be multiplied to get the actual value. If it is non-electrolytic, I equal to 1. M is same for both. So what should be the answer? I give you the direction, you can just tell me, just think it and try to tell me what should be the answer. Yeah, Ibrahim,
So just a second.
what should be the answer? Two solutions, equimolar, molarity same, but the boiling point elevation is higher for X, and for Y the boiling point elevation is less. So what could be the reason for that?
So maybe because let me just
So how that will affect? And what about you, Jasleen? What do you feel? Hmm. Yeah. If X is undergoing more dissociation, means I is going to be higher for X. Right? Means X is being the molality is same for both X and Y, but effective concentration of particles will be more in X. X is undergoing more dissociation. I is going to be more, and if more number of particles are formed, because it is a colligative property, depends upon the number of particles. So the boiling point is higher for X and lower for Y. Got it? Right? So because it is actually about the Ventov factor, understanding of Ventov factor. That molality is the original concentration which we put into the solution. But how that disintegrate, how many particles are formed, that matters. Okay. And which one of them lead to more number of particles? If X is causing more number of particles due to dissociation, ultimately X is the winner and it will have more number of more particles and more higher boiling point elevation and lower freezing, and freezing point depression will also be higher. So C is the right option. Got it? So this is a very good question, very simple also. In NEET only it was asked. So let's cover it on the next step. Okay. With some more very tricky questions which were asked in NEET. Okay. Some